Hey class, Absolute 5 here, and today we're going to talk about adding polynomials. Okay, so to add polynomials, all you simply have to do is just combine all like terms. That's it. Now, when I say combine, let me specify when I say combine. So in this example, we have 4x to the third minus 6x squared plus 2x plus 7 plus parentheses 5x squared minus 2x. Okay. I'm going to rewrite this again, but I'm going to remove the parentheses now. Okay. Now, when you say combine like terms, we don't mean literally combine every... Okay. You have to combine the polynomial with the exact same base, with the exact same exponent as well. The degree has to be the same. So, for example, I just can't combine 4x to the third with 6x to the second. No, that's not what I mean by combine all like terms. Well, when I talk about combining like terms, I'm talking about, you see the degree here is 2. I have to find another exponent here that has the exact same degree, which is this 2 there. So, since I know I can combine these two, I don't see a 3, so I'm going to leave 4x to the third alone. So I'm going to rewrite this as 6x squared plus 5x squared plus 2x minus 2x plus 7. I just reorder it where I'm just combining the exponent to the second degree, and I'm combining the other exponents that only have degree 1. That's why I reorder it. Now I'm going to combine these two. So now when I say combine, all we're going to do is pretend that these are like regular numbers. So don't think of it as, oh, I gotta multiply the exponents or I gotta add the exponents. No. Treat them as regular numbers. So you have negative 6 plus 5, which is what? Negative 1. Or in this case, you could write 4x to the third minus 1x squared, or just negative x squared, plus, now the 2x minus 2x, they both cancel, so you don't write that. You just write plus 7, or you just write as 4x to the third minus x squared plus 7 as your answer. So let's try another one. Let's try another example here to really understand what are we doing here. We can do a few examples. So if I have negative 2x squared plus 5x plus 1, not plus, minus 1 plus parentheses negative 2x squared plus x plus 3. The reason why we write parentheses is because we don't want to first confuse the person when you first give them the problem. Afterwards, you can remove it then to then figure out what you want to do. So, well, let's think about this. What do I write here? Do I write this? No, you don't, because you don't know what you're doing. So essentially what you're technically doing, you're technically distributing the plus sign into every single other sign that's in the parentheses. So if I have a positive times a negative, it's going to be negative. If I have a positive times a positive, it's going to be positive, and positive times a positive is still positive. That's why we have those parentheses there, for you to distribute the plus sign. I should have explained that in the first example. But that's what you have to do. All right, so I'm going to do the same thing. I'm going to underline the exponents that have the exact same powers, or in this case, the same degree. So therefore, I'm going to rewrite this as negative 2x squared, negative 2x squared plus 5x minus 1 plus 3. I get negative 4x squared plus 6x minus, plus 2. How to get the 6x is because, remember, it's 5x plus x, there's a little 1 here. 5 plus 1, 6. Let's move on to another example. Let's have parentheses 7y to the third minus 2y squared plus 7 parentheses plus, oopsie, parentheses 6y squared plus 1. All right, now what do I get? I get 7y to the third minus 2y squared plus 7 plus 6y squared plus 1. Again, I'm going to reorder this as 7y to the third plus 6, oopsie, not plus, minus 2y squared, because I want to combine these two, so it'll be 6y squared, plus 7 plus 1. I get 7y to the third, negative 2 plus 6, so that's positive 4y to the third plus 8. Lastly, I'll give you guys one more example for homework. Actually, no, I'll do one more, then I'll give you one for homework. One last one, why not? Why not? Just one more for the ride home. Okay, so again, now you notice we have a fifth power here. So you have to consider, okay, do I have another fifth power I can combine? You can't. So I'm going to, again, do the same steps. Remove the parentheses first, because we know positive times positive, positive, positive times negative is still going to be negative. So the thing is, you have to remember, the plus sign doesn't necessarily really change anything when you multiply it to anything. So everything kind of just stays the same. So afterwards, again, I'm going to underline the things I'm going to be combining. Not the thing, excuse me. I'm going to be combining the terms that have the same degree. Well, the polynomials, that's probably better to say. No. Terms is fine. Terms is better, if anything. Okay, so now I'm going to combine these two. The 7, I'm going to leave this alone. The 3x to the fifth, I'm leaving that alone. Minus 7x to the third plus 3x to the third would be minus 4x to the third minus, because these two cancel, minus 1 as my final answer. Homework, optional as always. Try to do this one. 5x squared minus 2x plus 1 plus negative 6x squared plus x minus 1. That will be your homework. And leave your answer down in the comment section below. So that's the lesson for you guys. I hope you enjoyed it. Be sure to like, share, and subscribe to my channel. Mash that bell button for more content, and I'll see you next time with another video. This has been Absolute 5. I'm Roger Palomino. Math is infinite because there are infinitely many possibilities. And don't forget, guys, don't hate, calculate.